Had a great spring break. We're going to finish up 6-6 here. So this is part 1. This is part 2, but this is a review of part 1. So remember that whatever the denominator is in your rational exponent goes to the outside here. So this is a negative exponent, so it's going to be written as 1 over 81 to the 1/4, which is the same as 1 over the 4th root of 81, because the denominator goes on the outside, or is our index. So again, if you need to rewatch that, please do so. And so the 4th root of 81, so are there any perfect roots, 4th roots in 81? Well, 81 is a perfect 4th root, and it is 3, so it's 1/3 is our answer. Now for this one here, there's a couple ways that you can write this. You can write this as the cube root of 216 squared, if you want to write it like that. We could write it as 216 to the 1/3 to the second. But when you do this in your calculator, just make sure you put your parentheses in the right spots. So the cube root of 216 is 6, and then we have it to the second power. And so 6 to the second power is 36, and that would be our answer. Again, this is just a review of that previous video. Here we have r to the negative 4/5. So let's write this with a positive exponent. And then we can't have rational exponents in the denominator, so how do we make this a whole number? Well, we can times it by r to the 1/5, because when you multiply, remember, when you multiply bases, you add the exponents. So that would end up being r to the 5/5, which is just r to the 1st, which is what we want. So if I'm going to multiply the denominator by r to the 1/5, I got to multiply the numerator by r to the 1/5 as well. So then what we have here is r to the 1/5 over r. And since we started with rational exponents, we're going to end with rational exponents as well. If you did write it as the 5th root of r over r, that's fine. But again, if we start with rational exponents, we want to end with rational exponents as well. So the new stuff here is simplifying radical expressions. So when we do this, and you might have saw this on the test as well, you're going to be assessed on this soon. When simplifying radical expressions, use rational exponents and find the same base. So we're going to change these two rational exponents here. So this is going to be 27 to the 1/4, and then it's going to be 3 to the 1/2. Now, we want to make the same base here, so we can go ahead and subtract our exponents. So can we make 27 be a base of 3? Yes, we can, because 27 is 3 to the 3rd. So we can write this as 3 to the 3rd to the 1/4 over 3 to the 1/2. Now we have the same base, and that's what we want. We want that same base. So now we get 3 to the 3/4 over 3 to the 1/2. And when we have the same base, we can subtract the exponents. We got to get common denominators. So it's 3 to the 3/4 over 3 to the 2/4. And we end up with 3 to the 1/4, because when we subtract these, and we're going to write our answer in radical form, so it's going to be the 4th root of 3 is our answer. So now let's try this one here. This one's a little bit easier because we don't have to have, we're not dividing. So what we can do is we can split this up into 64. We can do the 1/3 of that, or the 1/3 root of 64, the 3rd root of 64 rather, which is just 4. It comes out nice. And then we have z to the 6th to the 1/3. And so z to the 6th to the 1/3 is going to be z squared for that one, which that's kind of a review of that last section as well, but you'll see that again. So let's try some more examples here. So again, when you're dividing, you want to get that same base. So why don't you guys go ahead and see if you can figure out what the same base is. All right, so we write it as rational exponents. And so then when we do that, we can write 32 as a base of 2, and it's 2 to the 5th. and then we still have 2 to the third. So this is going to be 2 to the 5/4 over 2 to the 1/3. And common denominator here, because we got to subtract them, we want it to be 12, so it's going to be 3 over 3. And this one's going to be multiplied by 4 over 4, so we get 2 to the 15th 12ths over 2 to the 4 12ths. And we end up with 2 to the 11th 12ths because we subtract. And we want to write it in radical form, so remember the denominator comes out to be our exponent, or our index rather. So it's going to be the 12th root of 2 to the 11th would be our answer. Now this one here, we're going to use some conjugate, because remember the 1/2 power means that we are, hold on here, got to turn my lights on, my lights turned off. The 1/2 power means the square root. So I'm going to write it as the square root here because I think it's easier since we have dealt with the conjugate before. So this is actually the square root of x minus 2 over 3 square roots of x plus 2. Now, since we have the square root and we're adding a number, we got to multiply by the conjugate. So when we do that, I'm going to multiply by 3 square root of x minus 2. 3 square root of x minus 2 on top. And we're going to go ahead and FOIL. So why don't you guys go ahead and pause the video and do this now. Okay, so this is what I got so far. On the denominator, the middle term cancels out, so you get 9x minus 4. And in the numerator, we can go ahead and combine some like terms here. We can go ahead and combine these. So we end up with 3x minus 8 square root of x plus 4 over 9x minus 4. Now, since we started with rational exponents here, we're going to go ahead and rewrite our answer with rational exponents. So that's going to be 3x minus 8x to the 1/2 plus 4 over 9x minus 4. So if you did not get that answer right, or if you're having questions about that, go ahead and pause the video, rewind, rewatch it, and see if you can figure it out, how we got that. All right, see if you can figure that out. And also, if you need more help in your textbook, there's an example on page 425 as well. And we're going to go over this in class, do more practice with this, because you're going to be assessed on this very soon. So yeah, that's all I have for you. Welcome back from spring break in 2015. Adios.